14 billion years ago, there was nothing. No stars, no planets, no light, not even empty space as we know it today. Then, in less than a second, something incredible happened. Nothing exploded and transformed into everything that exists. First came pure energy, hotter than anything we can imagine. Then this energy turned into tiny particles which joined to form atoms, which created stars, which built galaxies. But here's the mystery that keeps scientists awake at night. How is it possible that absolutely nothing transformed into trillions of galaxies full of life and beauty? And if nothing created all of this once, could it happen again? Subscribe to the channel. Leave your like and comment which part of the world you're watching from, because now I'm going to tell you everything. Have you ever wondered where everything really comes from? Imagine you are looking all around, at the sky, at the ground, at your hands. Where did everything begin? This is a question that has made people curious for as long as anyone can remember. The story of how the universe began is full of mystery, strange ideas, and big questions that no one has answered for sure. Scientists spend many years asking, how did everything start? About 14 billion years ago, there was no sky, no earth, no stars, and not even space or time. There was nothing at all. But how can nothing exist and then become the world we see? This is our great puzzle. Nobody can see back that far with their eyes or with a camera. There are no old pictures from those times. Still, scientists have found clues that help them put the story together. When they look carefully at the universe with big telescopes or do math on computers, they notice things that tell them about the very early days. They try to use these pieces of information to understand the moment when nothing changed into everything. Before the beginning, there was no place, and there was no before. These words are hard to imagine. If you try to picture nothing, your mind probably thinks of a dark, empty box. But even that box is still something. Scientists say that before the universe began, there was not even space for a box or time for anything to happen. There was not even emptiness. Then suddenly, in a moment too small to measure, everything changed. All of the energy and all of the matter that make up our whole universe appeared from what looked like nothing. This surprising moment is called the Big Bang. The name Big Bang can make some people think of a loud noise or a big wild explosion. But the beginning was not really like a bomb going off in space. In fact, it was not inside anything at all, because even space did not exist before the Big Bang. In that first moment, space and time started together. This means there was no before. When the Big Bang happened, the universe began. This idea is very difficult to feel in your mind because we live with space and time all around us every day. Scientists use special ideas and very careful thinking to study what happened. They ask hard questions and search for answers by looking at stars and galaxies, and by doing experiments. Why does this first moment matter to us? Every single star in the sky, every planet, every rock, every person, everything that fills up the universe comes from this first event. Without the Big Bang, there would not be a sky or people to think about questions at all. Our whole world and every story comes from that tiny beginning. After everything appeared in the Big Bang, at first there were no people, no trees, and not even solid ground. There were not even atoms or light yet. The universe was only full of very pure, very hot energy. This energy did not fill a place because place itself was only just starting. For a very small instant, the entire universe was smaller than any tiny thing you can think of. All the matter and energy was packed together. Scientists have different ways of talking about nothing and everything. Before the Big Bang, nothing could move or happen. With the Big Bang, things could finally have a direction and could change. Space and time could exist, so things could start, move, and end. Some people find it hard to believe that something could come from nothing. This makes sense because in everyday life, we never see something just appear from nothing at all. But in the world of science, very strange things can happen when we look at the biggest or smallest scales. Many scientists do not say they believe in magic. Instead, they try to make sense of what happened by using what they can measure about the universe we have now. They use these measurements to learn about that first moment and the rules behind it. When scientists talk about the universe's beginning, they use math, physics, and careful thinking. They also use proofs, signs that show what probably happened. These proofs often come from light and energy we can measure today. For example, when they look far into space with special tools, they can see old light that began its journey very soon after the start of the universe. They also see that the universe is stretching out and growing bigger even now. These clues help them make their best guess about the past. One of the puzzling things about the Big Bang is that it is not a normal kind of creation. There was no empty space waiting to be filled. Instead, inside that first instant, the universe itself, the space, the time, all the rules, all the energy came into existence. It is like the rules of the game started at the same time as the pieces for the game and the board. The universe is more than just all the stuff you can see. It is also the space holding it and the time that things use to change. Since people cannot travel back to see the Big Bang, they try to understand by using what they can see now. They notice that if they imagine the universe running backwards through time, all the galaxies and stars would come closer and closer together. If they keep going backward, everything joins up in one small place. This is why scientists think the universe began from a single moment and a single starting point. Some people also ask, where did the Big Bang happen? This question is tricky because the Big Bang did not happen in one small part of space. Instead, the Big Bang happened everywhere at once because space itself began expanding. There was no outside, only the inside that was growing. It is also normal for people to want to know what was there before the Big Bang, or what caused it. Scientists are still searching for these answers. Some say that nothing we know of existed before the Big Bang, because time itself did not exist. Others have new ideas, sometimes thinking about other universes or different kinds of nothing. But nobody has proof for those ideas yet. What we do know is that after the Big Bang, everything that would become stars, planets, and life was set in motion. The Big Bang gave our universe its beginning. Everything that happens after that moment is connected to it. Scientists want to know why the universe started. They want to know why the rules of nature are just right to let things like stars and people exist. They say that if the rules were only a little different, maybe nothing would have formed. Maybe there would be no light, no planets, no people. They call this a mystery and keep looking for answers. The story of how the universe began is not only a question for scientists. It is something that everyone can wonder about. Children ask where the world came from. Grown-ups watch the sky and think about the start of everything they know. When you look up at night and see stars, you are actually seeing a sign of the universe's long history. Every little thing you eat, every breath you take, and every drop of water comes from very old events that started at the beginning. Even you, sitting or standing right now, are made from tiny pieces that once were part of the very first moment of time. Every day, scientists are trying to learn more. They build better telescopes. They try new experiments. They write down their ideas and check them again and again. With each discovery, they add to the story. The search for answers connects everyone because the story of the beginning is the story of all of us. We do not yet know all the secrets of the beginning. Maybe we never will. But each time we ask new questions, we move a little closer to understanding. The universe is here. We are here. And the biggest mystery is how everything came from nothing in just one very important moment. The moment the universe began, everything started to change very quickly. From nothing, all the matter and energy that fill the universe suddenly appeared. The universe was extremely hot and dense. There were no stars, no planets, no people, and not even tiny atoms. What filled everything was energy. Pure and powerful energy, squeezed into a tiny, tiny space. At the very start, this energy was not spread out. It was packed together, much more than anything we know today. This energy did not have a shape or form. Space itself was growing, and there was not yet anywhere for objects to be. In this beginning, the whole universe could fit into a space so small that it is hard for anyone to understand. Time itself had just begun. Each moment right after the beginning was the first time anything could happen. Energy was everywhere, and it was incredibly hot. Scientists believe that in less than 1/1,000,000th of a second, this energy filled all of space and started to move apart. The temperature was so high that it is hard to describe. It was much hotter than the center of any star, much hotter than any fire, hotter than anything people have ever found. This first period is called the Big Bang, but it was not a normal kind of explosion. The Big Bang was the beginning of space and time and all the things that would ever exist. There was no air, no light, and not even darkness in the way we think of it. There were no objects, only energy, with space and time growing together. Scientists spend many years trying to understand what happened in that first instant. They use big machines to study tiny particles. They look at old light in the universe and use very powerful computers to test ideas. They cannot see the start directly, but every sign and clue they find tells a little bit more of the story. They know that everything that happened after the first energy appeared is linked to the world we live in now. After the universe began, energy did not stay packed together. It started to spread out as space expanded. As energy moved apart, the temperature became just a little less hot. The universe did not cool down much right away, but even a small drop in temperature was important. It allowed the energy to start turning into something new. Energy and matter are linked in a special way. When there is enough energy and the conditions are right, small bits of matter can be made from energy. In those earliest moments, the universe changed every tiny fraction of a second. The pure energy filling space began to make the first tiny particles. These particles were not yet atoms. They were even smaller than atoms that exist today. These first particles are the building blocks of everything. The first particles to form were called quarks and electrons. Quarks are very, very small. They are so small that they cannot be seen with the eyes, and even the strongest microscopes cannot show them. Electrons are small too, but a bit bigger than quarks. Quarks and electrons are the pieces that make up everything in the world, including the stars, the air, the water, and living things. Quarks did not stay alone for long. Soon after they appeared, quarks joined together in small groups. When 3 quarks joined, they made protons or neutrons. Protons and neutrons are much larger than quarks, but still much too small to see. These are very important because protons and neutrons later became the centers of atoms, called nuclei. For a while, the universe was still so hot and crowded that quarks and electrons were flying everywhere, bumping into each other at very high speeds. There were no atoms yet, only a hot sea of particles mixing with energy. Protons and neutrons could not stay stuck together for very long. Any time they tried to join, the energy around them was so strong that it broke them apart again. As the universe stretched, energy kept spreading out, and the temperature dropped slowly. After a very short time, a few minutes after the beginning, something important happened. the universe became just cool enough for protons and neutrons to stick together without breaking apart. They joined in small groups called nuclei. A nucleus is the center of an atom. At first, almost all of the nuclei that formed were made with one proton, which would later become the basic part of an atom called hydrogen. Some nuclei formed with 2 protons and 2 neutrons. These became the centers of helium atoms. Helium is a very light gas that is still found in stars and balloons today. This first period of change set the stage for everything else that would come. From the start, the universe was filled with energy, but as it grew, the energy created the simple building blocks of matter. Hydrogen and helium nuclei were made, but there were no complete atoms yet. Electrons continued moving freely in all directions, not yet joined with the tiny nuclei. During this time, there was still no light in the way we see light now. The universe was so packed with free electrons and energy that photons, which are the tiny packets of light, could not travel very far. Every time a photon tried to move, it would hit an electron and bounce away. This meant the universe was unable to let light go very far. Everything was mixed together, very bright and hot, but also cloudy because light could not travel openly. Inside those first few minutes, things changed very fast. The main work was turning energy into matter, and then those new pieces of matter started to join. The universe was growing and cooling, but it was still not a place anyone could visit. There were no planets, no stars, no empty space. There was just a thick, hot soup of particles, energy, and light bouncing in all directions. Scientists call this period the era of nucleosynthesis. This word means the making of new nuclei. During nucleosynthesis, the first matter came together. Almost all the matter became hydrogen and helium, and just a tiny amount became heavier elements like lithium. These elements are still important because they are part of everything we see now. The universe kept on growing bigger and cooler. After the first few minutes, the making of new nuclei slowed down. The temperature dropped so low that most of the reactions stopped. There were still many free electrons traveling around, but all the protons and neutrons had joined into nuclei. For about the next 380,000 years, the universe was still flooded with energy and free particles. No atoms had fully formed yet. Throughout this time, the universe was changing, but the signs of what happened were left behind. The light and energy from this era are still here, but much weaker now. Scientists use special detectors to find this old light and learn more about the early days. By studying these clues, they can understand what happened step by step as the universe grew. It is important to know that all the matter in planets, stars, and even our bodies started off as this very simple matter, mostly hydrogen and helium. The universe did not start with gold or diamond or water or living things. At first, it was only these plain building blocks. Over billions of years, all the complex things in the world would be made from these first simple nuclei. Scientists use big machines called particle accelerators to learn about these first moments of the universe. These accelerators crash tiny pieces of matter together at very high speeds to see what kinds of particles are made. In this way, they try to understand what conditions were like just after the Big Bang. Each new piece of information helps build a clearer picture of how energy became matter and how matter joined into the basic nuclei. Even though all of this happened very quickly, each step was important. If the universe had not started cooling when it did, the particles would never have joined. There would be no atoms and no stars. Everything we know depended on these steps happening in the right order and at the right moments. As the universe continued to grow and cool, it got close to another big change. Electrons and nuclei would soon be able to join, making real atoms for the first time. When this happened, light could finally move freely, and the universe would become clear instead of cloudy. That would be a very important step in the story of everything. But in this time, just after the Big Bang, the focus was still on energy turning to matter and on how the first simple things formed. The story of the universe is long, and this early part is about building the basic pieces that would create everything else that comes later. The idea that all things come from a single beginning gives people much to think about. Scientists keep trying to find new clues about this process. They pay attention to how much hydrogen and helium are in space, and they study the ancient light that still fills the universe today. These clues are like a map, showing what happened when everything was very new. All of the things you see today are made from atoms. These atoms started as pure energy in a place that was once smaller than a grain of sand. But the universe did not stay small or simple for very long. The steps that began with energy not only allowed matter to form, but opened the way for even greater changes that would follow. As time moved forward, the universe changed again and again. From the very first burst of energy to the creation of the smallest pieces of matter, every part of this story is connected. Today, scientists know that the process did not stop with hydrogen and helium. They know that bigger, stranger things would still happen as the universe kept growing and cooling. Matter would join into more complex structures. Light would finally be able to fill the universe, and new forces would begin shaping everything that we see and know. This ongoing change is what made the universe a place for stars, galaxies, and life to appear much, much later. Each idea about the Big Bang and the first particles adds to our understanding of where everything comes from. The energy and matter that filled the beginning did not stop changing. As time moved on, the universe became ready for the next important steps that would lead to light, galaxies, and the whole world as we see it today. As the universe continued to grow and cool, things began to shift in new and important ways. The first, simple parts of matter, mostly hydrogen and helium nuclei, were surrounded by many fast-moving electrons. The universe was still filled with energy and very hot light. For a very long time, this hot and thick mix kept light trapped. Light could not move very far before it bounced off something and changed direction again. But as the universe became less hot, a big turning point came. The space between the particles grew wider. As this happened, the energy inside dropped even more. New things became possible that could never happen before. Bit by bit, some of the early chaos settled down, and the universe got ready for more change. Scientists say the universe started to expand. To expand is to get bigger. At first, the universe was extremely small, so small that nobody can truly picture it. In a tiny, tiny moment, the space itself began to get much bigger, not slowly, but faster than anything we ever see in our daily lives. This very fast growth of space is called inflation. It does not mean things inside the universe exploded outward into empty space, but that the universe itself, including space, was stretching and making more room for everything. Inflation happened in far less than one tiny part of a second. Almost everything we see today, all the galaxies and stars, started from this very small, very fast change. Inflation was not like anything we see now. There was no air, there were no atoms, only the parts that would later make them. The universe did not have a shape you could draw or a place you could travel to. There was only the growing world getting bigger at every moment. Once inflation ended, the universe was still unbelievably hot and full of energy, but it was much bigger than before. Even though it kept growing after inflation, it never became slow or calm right away. The universe never stopped stretching. It grows even now. Today, scientists measure space and notice that galaxies are still moving away from one another. Not only are they moving, but the distances between groups of stars are growing. Each point in space seems to be moving apart from every other point. This is not because everything is flying outward from some special center, but because space itself keeps getting bigger everywhere. Even today, billions of years later, this expansion has not ended. Scientists use special tools and tricks to measure these changes. They look for signs in faraway galaxies, in old light waves, and in the way objects move throughout space. The proof comes from many different clues. One important clue is called redshift. When scientists look far into space, they notice light coming from stars, and galaxies does not have the same color it did when it left those stars. The light looks more red because its waves stretch as space gets bigger. The farther away a galaxy is, the more its light is shifted. This shows that the galaxies are moving apart as space stretches. The discovery of redshift was one of the biggest steps in understanding how the universe grows. When astronomers first saw this, they realized the whole universe must be getting bigger, not just a few parts moving around. It meant that the universe had a beginning and is still changing. It means space is not still or quiet, but always active. Scientists find other clues too. When they carefully count the amount of hydrogen and helium in the universe, they see the numbers match what would be made if the universe was once small, dense, and hot, then grew bigger and cooler. Everything fits together to tell the story of expansion. As the universe expanded, things inside had more room and the temperature dropped steadily. When everything was pressed close together, energy and particles moved quickly. But when there was more space, they slowed down. This cooling and spreading led to new changes, giving particles a chance to join in new ways. It is important to understand that expanding means more than just things moving. It also means that space itself is changing. The size of the whole universe is always getting bigger. Space is not a thing you can touch, but it is real, and it can grow or stretch. Even right now, the space between faraway stars and galaxies is slowly stretching out. This expansion is a key reason why our universe looks the way it does today. Because space grew so fast at the beginning, the matter and energy did not have time to gather in just one spot. Everything was pushed apart and spread through the universe. This made the universe very even, with nearly the same amount of matter everywhere at first. Later, small differences would appear, but to begin with, everything was almost the same everywhere. For millions of years, this stretching continued. At the same time, the first simple pieces of matter slowly started to join. Those building blocks of hydrogen and helium with electrons swirling around slowly came together in small, thin clouds. There were no stars or galaxies yet. For a long time, the universe was just dark, empty space, with tiny bits of simple matter floating through it. As the universe grew, spots with a little more matter than others began to pull in the matter near them. This happened because of gravity. Gravity is a force that attracts things with mass toward each other. Even though everything was spread out, gravity slowly started to gather and pull matter into larger and larger clumps. These clumps would become very important later. Even now, the expansion of the universe is happening all around us. When astronomers look at light from far-off galaxies, they use their measurements to guess how fast the universe is expanding. They have found that not only is the universe still growing, but that the expansion is speeding up. This means space is getting bigger at a faster rate today compared to the past. Nobody fully knows why this happens. Some scientists think something called dark energy is pushing space to grow faster and faster. They study this mystery by watching how galaxies move away from each other over vast distances. Dark energy does not feel like anything familiar. It does not shine or make heat, but it must be there because only with its help can space stretch faster as time goes on. The discovery that the expansion is speeding up surprised many people. For a long time, scientists believed gravity might slow the expansion down. Instead, they found it is getting faster. All around, the universe is always shifting and changing. When thinking about the universe growing, you might wonder if there is an edge of the universe, or if there is something beyond it. Scientists say there is no edge like a wall or a limit. The universe is not stretching into empty space. The universe itself is all there is. The expansion is everywhere, and every part grows at the same time. There is nothing outside the universe, at least as far as anyone knows now. Little by little, the universe became less crowded and less hot. Now there was enough space and low enough temperatures for particles to come together more calmly. For a long time, energy was still so high that new things could not form and survive. But with more expansion and cooling, the next big change became possible. This is why the story of expansion is so important. Without space growing, matter would not have had a chance to come together into anything solid or stable. Hydrogen and helium could not have gathered to make stars. Light could not have traveled across space for anyone to see it. The growing and stretching of the universe gave everything more room, making it possible for small changes to add up over long periods. If you look at the stars tonight, remember that their light began its journey many years ago. Some of the stars you see are so far away that their light left them before you were even born. This is possible because of expansion. The more the universe grows, the farther away galaxies become, and the longer it takes for their light to reach us. This means when you look into the sky, you are looking back in time. The light shows you the universe as it was many millions or even billions of years ago. Because of the universe's huge size, it is impossible to see everything at once. The farthest places are so far away that their light has not reached us yet. When we look far into space, we find not only distance, but also deep time. We find clues to the early parts of the universe. Each bit of information tells us more about the first times when expansion was new. Scientists are always working to learn about expansion and inflation. They use telescopes on the ground and in space. They build machines that look at waves sent across the universe by ancient events. By joining all these clues, they learn how fast the universe grows, how much it has changed, and what could happen far in the future. The idea of inflation, that the universe grew in a huge stretch at the beginning, helps to answer some old puzzles. For example, it helps explain why the universe looks almost the same in every direction. That fast growth smoothed everything out. It also helps explain why the universe is not completely empty, but has spots with more matter than others. These spots would become the seeds for galaxies and stars to grow much later. Even the changes in temperature in the old light that fills the universe can be explained this way. That ancient light tells us about the universe during its first hundreds of thousands of years. Scientists study small differences in this light to learn about inflation and expansion. They have found that these small changes match the story of a universe that grew very quickly and then slowed down to keep stretching for billions of years. Every discovery about expansion also tells us about our own place in the universe. We now know that our home, our sun, our planet, and everything we see came from a process that started almost 14 billion years ago with the fastest stretching of space. All of time, all of change began with that first inflation and the continued growth of the universe. Everything you touch, see, or feel around you is part of this history. The growing and cooling universe made it possible for matter to join and to build everything we know. Over time, expansion allowed small things to join into bigger things. Later, This would make stars, galaxies, and planets. Now, as the universe continued to expand, the particles moved more slowly. The temperature dropped enough that something very important was about to happen. The nuclei of hydrogen and helium made earlier were finally able to grab onto electrons. This would mean the first atoms could be born. When atoms formed, light would be free at last to move across space. This moment would open the whole universe to new changes and new possibilities. The story of the universe was getting ready for another great step. After many ages of cooling and growing, the universe was finally ready for the next big step. The early changes made simple building blocks like the nuclei of hydrogen and helium. The space between particles increased as the universe expanded, and the temperature was no longer as extremely hot as before. The fast, wild movement of particles was now becoming less wild. The energy was still high, but now the universe was cool enough for something new to happen. The free electrons that had been racing everywhere finally started to slow down. The hot energy was no longer strong enough to break their bonds with other particles. Because of this, electrons began to link with the waiting nuclei of hydrogen and helium. When an electron joins a nucleus, they make an atom. This meant that, for the very first time, real atoms could exist. This did not happen in just one place. It happened everywhere, all across the growing universe. This joining of electrons and nuclei did not happen instantly. It was a slow process that took place over many thousands of years. For nearly 380,000 years after the universe began, free electrons floated alone. But as the temperature dropped more each day, everywhere in space, more and more electrons found their place around a nucleus. These new atoms were the first complete pieces of matter. Almost all of the atoms were hydrogen, the simplest and lightest kind. A smaller amount were helium. A tiny few were other light elements like lithium. The universe at this time was still very plain. There were no complex things. The world was still filled with a thin, gentle mist of these new atoms. They moved through space, sometimes joining together to make small clouds. The creation of the first atoms was important for another reason. Before this, light could not travel far. Every time a light particle or photon tried to go anywhere, it hit a free electron and changed direction. This kept the universe bright, but also blocked the light from moving freely. Once electrons joined with nuclei to make atoms, these barriers disappeared. The light was no longer trapped or bounced around so often. Photons could finally travel across space in straight paths. This moment changed everything. The universe became clear for the first time. Scientists call this great event recombination, because particles came together to make atoms, and at the same time decoupling, because the light became free and separated from matter. With so much of space clear, light spread far and wide. Even though it was weak and faint, this light is still traveling through the universe right now. It is called the cosmic microwave background. The cosmic microwave background is very special for science. It is the oldest light we can see anywhere. It is left over from the time when atoms first formed, and it carries with it a picture of what the world looked like at that time. Scientists use giant telescopes and special detectors to measure it. They find that it comes from every direction, filling all of space with a faint glow. This ancient light gives us a window into the earliest years of the universe. The cosmic microwave background tells us that the universe was almost the same everywhere at that time. The temperature and light were smooth and even, with only tiny differences. Scientists measure these tiny differences very carefully. By studying the small patches that are a bit hotter or colder than nearby areas, they learn where matter was a little denser or less dense. These small changes are the beginnings of all the things that would come later, like stars and galaxies. If you could see the universe as it was when this light was first set free, there would not be much to notice. Space would seem almost empty, filled with a soft, dim glow. There were no stars, no planets, no bright lights, only a thin mist of atoms floating through space. The slight lumps in this mist were what made some places just a bit thicker with matter. Over time, these places would gather more and more matter, and new things would slowly appear. Scientists spend a lot of time learning about the cosmic microwave background because it holds secrets from the very start. It was first discovered by accident in the year 1965 by two scientists who were trying to detect signals from space. Instead, they found a steady, quiet background noise coming from all directions. Later, people learned that this was the old light, stretched out by billions of years of the universe expanding. Today, many satellites and telescopes are used to carefully measure this ancient light. Each year, these devices take better pictures and find smaller details. The patterns in this old light match what we expect from a universe that started with the Big Bang, expanded, and cooled. It is one of the most important pieces of proof for the story of the universe's beginning. After the first atoms formed, the universe entered a period without much happening. Scientists call this the Dark Ages, but it was not completely dark. The cosmic microwave background filled space with a very dim glow, but there were no stars or galaxies to give off strong light. The universe was quiet. The simple atoms drifted gently, waiting for the next step in the story. Gravity began to do its slow work. All the while the universe expanded, gravity pulled on every piece of matter. Over many millions of years, the places where atoms were packed just a little closer together became more crowded. Gravity kept pulling more and more atoms to those places. Slowly, small clouds of hydrogen and helium started to form. These clouds grew, coming together to make clumps and then bigger clumps. The differences in the cosmic microwave background, those tiny hot and cold spots, were where these clumps first appeared. They were very small, but gravity made them grow. The more matter that gathered in a spot, the stronger gravity became there, pulling in even more atoms. Eventually, these clumps would become the first structures in the universe. The universe at this stage was still very empty compared to what we see today. If you could travel through it, you would float for many years between atoms or clouds of gas. Still, the seeds for everything else were now planted. It only took time and gravity to make them grow. As millions of years passed, clouds of hydrogen and helium kept coming together. Some clouds stayed small, others became huge. When the clouds were big enough, the matter inside became very dense. As the atoms moved around and hit each other, the center of each cloud got hotter and hotter. When the core became hot and packed tightly, something amazing was about to happen. Inside the very biggest clouds, atoms pushed together under so much gravity that their centers, or nuclei, started to change. This process is called nuclear fusion. Nuclear fusion is when two simple atoms join and become a new, heavier atom, releasing energy as light and heat. This is the same process that makes stars shine. It is how our own sun makes light. But reaching the point where fusion could start was not easy. The clouds needed to be large enough. Their centers had to get very hot and dense. Only then could fusion begin, and real stars could be born. When the first stars lit up, the universe changed yet again. The Dark Ages were over, and the sky had its first true light. But before the first star could ever shine, many steps had to happen. The cooling of the universe, the making of the first atoms, the spreading of light, and the soft touch of gravity gathering matter, all these stages prepared the world for even more complex structures. The joining of electrons with nuclei to make atoms remains one of the most important moments in the story of everything. Before atoms, light was stuck and could not move far. After atoms, the light could travel freely, and the universe became much larger and more open. This change allowed information about the early universe to last for billions of years, and it let new things start to form. From this point, even more changes were possible. Atoms could now clump together without being torn apart by high energy. These clumps would later become the gas clouds and the first shining stars. The universe was on its way to making all the beautiful and complex things we can see in the night sky. Each step depended on the steps before it. If the universe had not cooled enough, electrons would not stay joined with nuclei, and atoms could not exist. If atoms had not formed, there would be no way for light to travel freely, and the sky would still be cloudy and closed. Every change built on the last, slowly shaping the world. Scientists are able to piece together this long, slow history by studying the effects that small changes in the early universe left behind. Every measurement of the cosmic microwave background, every detail in the light, helps us see what happened so long ago. Even the stars, planets, and our own bodies carry signs of these first times, because the very atoms inside us were once just pure energy and then the simplest of matter. The universe did not hurry. It took almost 400,000 years before the first atoms formed. It took many millions of years before the first stars would shine, but each step was necessary. The calm and order in today's world comes from these ancient changes. The quiet, patient joining of small particles made everything possible. Now, as you look up and see the stars or the darkness between them, remember that there was a time when no star yet had been born. There was only a gentle glow filling space, created in the first age of atoms. The story of the universe moved forward slowly, but it was preparing for the night skies to be filled with 1,000,000 lights. With atoms moving everywhere and light able to travel far for the first time, space became more than just emptiness. The very first clouds of gas started to collect, drawn together by gravity. This would eventually lead to something truly new, the beginning of stars and the first sources of bright, powerful light since the very start. The birth of atoms and the freedom of light set the stage for everything that followed. Gravity would continue its long work, and slowly matter would move and change again. The ancient light remains with us. It shows us where we came from and tells the story of a universe that is always growing, always changing, and always guiding the next steps in the story of everything that exists. After the first atoms formed and the ancient light was set free to travel, the universe entered a quieter and darker time. Everywhere, simple atoms like hydrogen and helium drifted through space. The universe expanded and cooled, but there were still no stars, planets, or galaxies anywhere, only a thin gas spread across vast emptiness. Everything was waiting for something new to begin. This time lasted for many millions of years. Gravity, the force that pulls objects together, was slowly shaping the next stage. Though the gas was thin and spread out, some areas had just a little more matter than others. These small differences came from the earliest moments, where the universe was not perfectly even. Even very tiny extra amounts of matter made certain spots more crowded than others. Because of gravity, the atoms in these crowded places began to pull in even more atoms. As a result, small clouds of hydrogen and helium started to form. Over long periods of time, gravity kept working. The slightly thicker parts of gas attracted more and more matter. These clouds grew larger and heavier. The centers of these clouds often became the most crowded. As more atoms gathered, they pressed closer together. The pressure in the center of each cloud increased, and the temperature there began to rise. Slowly, the centers became hotter and denser. When a cloud becomes big enough and squeezed enough at its core, something very important begins. the temperature inside rises to millions of degrees. Under so much heat and pressure, the hydrogen atoms start to join with each other. When two hydrogen nuclei come close enough, they join into one helium nucleus. This is called nuclear fusion. During fusion, a small part of the mass of the atoms changes into energy. This energy shines out from the center as light and heat. With the first signs of nuclear fusion, the universe finally had its first stars. These newborn stars were much larger and brighter than most of the stars in the sky today. They were made only from hydrogen and helium because heavier atoms did not exist yet. The formation of the first stars ended the long dark ages and brought true light to the universe for the first time. The light from these first stars began to travel across space. The energy released by each star pushed away and heated the gas around it. The space between stars started to clear, and the universe became brighter. These stars only lived for a short while, but they were powerful. Their bright light traveled for millions of years and can still be studied by scientists looking far into space today. Stars are born in groups. The first stars also formed in groups, making clusters. These groups of stars were held together by gravity. Soon, as more stars were born and more gas collected, the first galaxies appeared. A galaxy is a group of billions of stars, dust and gas, all held together by gravity. The earliest galaxies were smaller than most galaxies today, but over time many joined together to form larger ones. Inside a galaxy, stars can be older or younger. They come in different sizes and shine in different colors and brightness. Some galaxies are shaped like disks with arms that spin out from the center. Others are round or stretched out. Over billions of years, galaxies moved through space, sometimes coming close and sometimes joining together to make new, larger galaxies. The stars that formed after the Big Bang are very important for the story of the universe. Their lives bring new changes to the world. As stars burn through hydrogen and helium in their center, they make new types of atoms. The centers of the largest, hottest stars can produce heavier atoms like carbon, oxygen, and iron. These atoms are important. They are needed for planets, air, water, rocks, and even for life later on. When a big star finishes burning all the hydrogen and helium at its center, it cannot hold itself up anymore. The outer parts of the star collapse inwards very fast, and then the star explodes. This huge explosion is called a supernova. A supernova can shine brighter than a whole galaxy for a short time. All of the new, heavier atoms made inside the star are thrown out into space by this explosion. These pieces then float in space and can later be used to form new stars and planets. Not all stars explode. Some stars are smaller, and when they reach the end of their lives, they become quiet, small objects called white dwarfs. Others can turn into black holes or neutron stars, which are even stranger and denser than anything in everyday life. Each type of object made after a star's life adds new things to the universe and changes what comes next. As the first stars died, many more were born. The material from old stars mixed with the simple gases from before. New generations of stars had more kinds of atoms inside them than the first stars ever did. This change allowed new things to be created, including solid planets and, much later, living things. Life in a galaxy is shaped by the birth and death of stars. In our own galaxy, the Milky Way, stars are born in spinning clouds of dust and gas. They shine for millions to billions of years, depending on how big they are. Small stars live much longer, sometimes for tens of billions of years, while the largest, brightest stars live for only a few million years before exploding. As galaxies grew larger and changed, they collected gas and dust and sometimes collided with each other. When two galaxies joined together, it created a rush of movement, mixing stars, gas, and sometimes leading to big changes inside the galaxies. This made new clouds of gas gather and allowed more stars to form. Between the stars in every galaxy, there is emptiness, but also small amounts of gas and dust. When a star explodes, it sprays out particles that can travel across space for millions of years. Some dust and gas can collect in new clouds and begin the process of making new stars all over again. This cycle has been happening since the first stars were born. Galaxies are not all the same. Some are shaped like spirals with arms that curve away from a bright center. Others are smooth and round, and some look stretched or lumpy. Some galaxies are small with only a few million stars, while the largest can contain more than 1 trillion stars. Every galaxy has its own history. Our galaxy is called the Milky Way. It is a spiral galaxy with long curved arms. The Sun is just one ordinary star among hundreds of billions of stars in the Milky Way. Our solar system is placed far from the center, out on one of the arms. Earth is a small rocky planet circling the Sun, one of many planets in our solar system. When we look out into space, we can see billions of other galaxies. Each galaxy is full of stars. Some galaxies are very close to us, and some are so far away that their light takes more than 13 billion years to reach Earth. When scientists look far away into space, they are also looking back in time, seeing galaxies and stars as they were many, many years ago. There is more to the universe than the stars and the things we can see. Scientists have learned that most of the matter in the universe is invisible. This invisible matter does not make light, heat, or any signals we can sense in the usual ways. Scientists name this strange stuff dark matter. They know it is there because it pulls on stars and galaxies with gravity, affecting how they move and how galaxies change over time. There is also something called dark energy. Dark energy makes up most of the energy in the universe. This strange thing causes the expansion of the universe to speed up, making space grow faster and faster over time. Dark matter and dark energy shape the universe in big and small ways, but they are still great mysteries. Nobody fully understands what they really are, but by watching how galaxies move and change, scientists do know they exist. The universe is always active. Stars are always being born and dying. Galaxies keep moving and sometimes join together. Matter spreads out and collects. Over billions of years, all of these changes have made the universe a place filled with new shapes, new objects, and new possibilities. From the very first atoms to the birth of the first stars, the story of the universe is one of slow but constant change. The materials inside stars, including the things needed for planets and life, are made only through these changes. The universe had to grow, cool, and collect, step by step, before anything like our world could exist. As the process continued, some of the dust and gas left over from older stars started to stick together in the spaces around new stars. Over millions of years, these bits joined to form rocks, ice, and planets. Around many stars, whole systems of planets were born. This is how our own solar system was created, using the materials from many generations of stars that lived and died before the Sun and Earth were born. All the air, water, earth, and life we know comes from the same atoms born in the very early universe. Every living thing, including all people, is made of these atoms, which once floated as pure energy, turned into particles and atoms, and were later carried inside stars. When a person breathes or drinks water, they are using things made in stars and spread across space billions of years ago. The story of the first stars and galaxies is a story of patience and change. Each star lights up its own piece of the universe, but together, Billions of stars and galaxies fill space with light, color, and movement. The life of every star helps build up the world around us. All the heat, light, rocks, and even the life on Earth started as the simple matter that filled the universe after the Big Bang. Scientists keep studying these ancient times by watching stars, galaxies, and the oldest light in the universe. As new telescopes and tools are built, they find more details every year. They find new galaxies, learn how stars are made, and discover more about the materials needed for life. Every new fact adds another part to the great story of the universe, from the simplest, earliest moments to the rich, bright world today. The rise of the first stars was a turning point. Before them, the universe was empty, dark, and plain. With stars, there was energy, light, warmth, and the first real shapes and movement. As time passed, this allowed new things to happen, from the formation of planets to the beginnings of life. As the universe kept changing, stars grew old and died, spreading their matter far and wide. Galaxies grew and took new forms. Around some stars, the leftovers from old explosions began to come together in new ways. The slow, careful joining of dust, ice, and rock around young stars would one day lead to places like our own Earth. With every change, the universe became more interesting and more complex. The simple beginning gave way to a rich and varied world. What started as a hot, fast-growing mix of energy and simple matter ended up creating stars, galaxies, and everything we see and touch. The long story of the universe's birth and growth continues in the stars above, in the planets below, and in the life that looks up and asks questions about where it all began. As stars continued to shine and galaxies grew larger, another important process was taking place across the universe. The simple gases of hydrogen and helium, made after the Big Bang, drifted through space. Gravity was always at work, pulling these atoms together, little by little. Over time, some areas in space began to gather many more atoms than others. These areas slowly became thick clouds, invisible in the dark but filled with possibility. Gravity pulls all things that have mass. When even a small cloud of hydrogen and helium began to gather, gravity made it stronger over time. More and more atoms came together, and the cloud became bigger, chunk by chunk, across millions of years. Inside these clouds, the pressure grew higher and the center became warmer because the atoms were moving faster and bumping into each other over and over. When a cloud became very crowded, the temperature could reach millions of degrees. At this point, the center of the cloud was hot and dense enough for something new and powerful to start. This is the time when the first stars were born. Inside the crowded core of the cloud, hydrogen atoms began to join together and create helium atoms. When two hydrogen nuclei join to make one helium nucleus, a great amount of energy is set free. This energy is released as heat and light. The process is called nuclear fusion. It is what makes stars shine. The new, bright star lights up the cloud around it and begins to change its surroundings. Stars do not form all alone. Many stars are born in large groups from one big cloud. These groups are called star clusters. In these clusters, many stars shine close to one another, sometimes for millions of years. The stars in one cluster can be similar in age because they were formed from the same cloud at about the same time. The first stars in the universe were much larger than most stars today. These giant stars did not live for very long. They quickly used up the hydrogen in their centers by making nuclear fusion. When this hydrogen was finished, these giant stars could not stop themselves from collapsing and would explode, sending their matter out into space. Even though these first stars died quickly, they were very important. They spread heavier atoms like carbon and oxygen into space, making it possible for new kinds of stars and planets to form millions of years later. As the first and later generations of stars appeared, groups of stars began to come together to make galaxies. A galaxy is a giant collection of billions of stars, as well as gas, dust, and other objects. All galaxies are held together by gravity. Some galaxies are shaped like a thin disk with long arms, some are round, and others have more strange shapes. Over a very long time, galaxies can grow bigger as they pull in more stars and gas. Inside a galaxy, gravity keeps everything moving together. The stars travel around the center, sometimes taking hundreds of millions of years to circle once. Clouds of gas and dust also move through the galaxy, and new stars can be made when these clouds come together and become dense and hot enough. Galaxies are not spread out evenly in space. Some areas have more galaxies, making clusters or groups with many galaxies close together. Other areas have very few galaxies. Sometimes galaxies move closer and even join together, becoming one larger galaxy. When this happens, the stars and gas inside can mix, and more new stars can be created in bright, active regions. Between the stars in a galaxy is much empty space, but there is always some gas and dust floating there. The clouds of cold hydrogen and helium are where new stars begin to form. The process is very slow. A single cloud can take millions of years before it becomes dense enough to start making new stars. The birth of stars inside these gas clouds brings more light into the galaxy. Each new star adds its own energy and warmth to its surroundings. Some stars are much bigger and brighter than others, but even smaller stars can shine for billions of years. The life of a star depends on its size. Large stars burn their fuel quickly and live short lives. Smaller stars use their fuel slowly and can last many billions of years. Gravity is not only important for stars and galaxies, it is the reason why matter in the universe keeps coming together, forming larger and more complex objects. As galaxies became more crowded with stars and gas, gravity also pulled together smaller pieces of matter inside galaxies. These would become the early building blocks for planets and moons. Inside galaxies, as stars are born and die, the material from exploded stars spreads out and mixes with the gas around them. This mixture of gas and heavier atoms lets the next generation of stars be formed with different kinds of atoms. This is important because it allows new things to be made, including the rocky substances needed for planets like Earth. Over time, the dust and gas become richer, and planets can form more easily as a result. At the very center of most galaxies, there is something very massive and mysterious, what scientists call a supermassive black hole. A black hole is a place where gravity is so strong that nothing, not even light, can escape from it. Supermassive black holes are much heavier than a star and are found in the centers of nearly every large galaxy. They help control the movement of stars nearby and can sometimes create bright bursts of energy that shine out into space. Stars and galaxies are not the only things affected by gravity. Over the billions of years since the Big Bang, gravity has helped shape everything in the universe. Planets, moons, star clusters, galaxies, and even larger groups are all held together by this force. The universe would not have the structure it does without gravity's slow but steady pull. Some of the matter in the universe is not visible. Scientists know about something called dark matter. Dark matter does not give off light or heat that we can see, but it pulls on galaxies and stars with gravity. Scientists can only notice dark matter by seeing how it changes the movement of stars and galaxies. This invisible matter is much more common than the matter we see, and it helps hold galaxies together. Gravity also played a part in creating another invisible part of the universe called dark energy. Dark energy is not like anything we see or touch. It makes up most of the energy in the universe and causes the expansion of the universe to speed up. The reason for this is still unknown. Scientists are still studying both dark matter and dark energy to understand how they work and what they are made of. As the universe grew older, galaxies arranged themselves into large groups called clusters. Some clusters contain only a few galaxies, and some hold thousands. These clusters can be joined together by even larger bands of matter, making huge structures across space. There are also large spaces with almost no galaxies, called voids. This pattern, clusters, bands, and voids, makes up what scientists call the cosmic web. Stars have different paths in their lives depending on their size. After a long time shining, a small star uses up its fuel, then cools down and becomes a white dwarf. A middle-sized star, like our Sun, will swell into a red giant and then shrink into a white dwarf. Large stars explode as supernovae and can become either neutron stars or black holes. Each type of star, as it lives and dies, spreads matter into space and changes the galaxy it lives in. Not all matter joins into stars. Large disks of leftover gas and dust in galaxies can circle young stars, where the building of planets and other smaller objects happens. As stars keep forming and dying, each cycle lets more heavy atoms collect, making it possible for richer and more diverse planets to develop. Some galaxies continue making new stars at a fast rate, while others slow down over time. The brightest young galaxies can be seen very far away, shining with the light of millions of new stars coming to life. The oldest galaxies may be more quiet, with fewer new stars forming within them. The process of gravity pulling atoms together never truly stops. As long as there is gas and dust, there can be new stars. Very large clouds in a galaxy can collapse and split into many parts, each one eventually becoming a star or a group of stars. Some stars form in pairs or in groups with other stars. These are called binary stars or star clusters. Later, as time passes, these groups can break apart, and the stars travel their own paths around the galaxy. The life inside galaxies is never still. Stars move around, new stars arrive, old ones end and give their material to the next generation. Dust and gas stream between the stars, sometimes pushed by shock waves from exploding stars, sometimes drifting quietly. The slow, constant work of gravity keeps everything moving, cycling, and building in new ways. Planets, moons, and other small objects are all built from matter left over around stars. As dust and small rocks stick together, they grow into larger bodies. If these grow big enough, their gravity makes them round and keeps pulling more matter in. Some gather gas and become giant planets. Others remain smaller and become rocky worlds like Earth. The birth of stars and galaxies from gas clouds is the simple but powerful story of how the universe becomes more complex over time. Every bit of progress comes from the same basic forces and materials created in the first moments after the Big Bang. With each new star, more atoms are made and sent out across space. Over the ages, this makes it possible for new planets, moons, and even life to appear. The cycle of birth, shining, and death in stars is at the heart of everything we see and know. Now, as you look up and see the stars, remember that every light in the sky, every galaxy seen through a telescope, is the result of countless ages of matter moving and coming together because of gravity. These processes began soon after the universe formed, and they never stopped changing and creating. The pull of gravity and the joining of atoms into clouds, stars, and planets made the universe turn from a plain, empty place into one filled with light, shapes, and life. The story of the universe continues in every star, every galaxy, and every planet that moves through the wide, dark space. Every change, every step leads to something new. The gathering of dust and gas around brand new stars, the birth of planets, and the creation of countless worlds all happen because the universe is always moving and always growing. The amazing process of building stars and galaxies from simple clouds of atoms is part of the same long story that connects to every planet, every rock, and every living thing. All of us are part of this great story, made possible by the slow joining of matter under gravity, the shining of stars, and the endless changes that keep the universe alive and moving forward. As galaxies filled space and stars continued to shine, scientists discovered that not everything in the universe could be seen. There were billions of bright stars and enormous galaxies, but something was missing in the way all these things moved and behaved. People wanted to know why galaxies held together, why stars stayed in their places as they spun around galaxies, and why the universe expanded in the way it did. The answer was hidden, out of sight, but it became very important to understand the real shape and path of the universe. When scientists looked at galaxies, they saw stars moving much faster around the edges than they expected. If only the things that could be seen were there, the gravity from the stars and gas would not be enough to keep galaxies together at the high speeds seen. The stars at the edges should have moved away, leaving galaxies broken apart, but that did not happen. Galaxies stayed whole and strong. Scientists knew something extra must be there, giving more gravity, but it could not be seen directly. This invisible part of the universe was given the name dark matter. Dark matter does not shine or give off heat or light. It cannot be touched or seen with any tool or with the eyes. It has mass and it pulls with gravity. Scientists think dark matter is everywhere in and around galaxies. Even though it cannot be seen, it makes up most of the matter in the entire universe. Stars, gas, and dust, which can be seen, are only a small part of what is really there. Dark matter shapes every galaxy. It acts like a hidden support, making sure stars stay in their paths around the galaxy. Giant halos of dark matter surround and stretch beyond every galaxy, sometimes forming invisible bridges between galaxies in the same group. When clusters of galaxies gather together, dark matter holds them tight with its strong gravity. Scientists study the effects of dark matter by looking at the way light from far objects bends when it passes through space. This effect is called gravitational lensing. The extra gravity from dark matter curves the path of light, letting astronomers map where dark matter is, although it cannot be seen. Careful study of many galaxies and clusters shows the presence of dark matter everywhere, shaping the universe's structure. Nobody yet knows exactly what dark matter is made of. Scientists think dark matter could be made from new kinds of particles that do not interact with light or other particles in the usual way. These particles are still a mystery. Many experiments all over the world try to catch signs of dark matter deep under mountains and in large labs, but it has not been found directly yet. Still, the signs of dark matter are strong, and scientists are sure that it is very real. Along with dark matter, there is another invisible part of the universe called dark energy. Scientists noticed that galaxies are moving away from each other at faster and faster speeds. This means that the expansion of the universe is speeding up. For a long time, people thought the pull of gravity might slow the universe down, but that was not what was seen. Instead, something mysterious pushes the universe to expand even faster. This is called dark energy. Dark energy makes up most of the energy in the universe, even more than dark matter. Nobody can see, touch, or feel dark energy, but its effects can be measured when astronomers look at faraway galaxies. Dark energy works everywhere, between galaxies, and even in the empty spaces where there is almost nothing. Its push gets stronger as the universe gets bigger. Together, dark matter and dark energy are the largest parts of the whole universe. The things we can see, stars, planets, gas, dust, are only a tiny part. The hidden parts shape everything: the way galaxies move, the way the universe grows, and even how the stars and planets came to be. Galaxies themselves come in many shapes and sizes. Some are large and have beautiful spiral arms. These spiral galaxies have bright centers with arms winding outward, filled with clouds of gas, dust, and young shining stars. Some galaxies are smaller and very round with no spiral arms. These are called elliptical galaxies. Others are shaped in strange ways, stretched, pulled, or even mixed when galaxies come close or when they crash into each other. In every galaxy, stars are born in clusters within big clouds of gas and dust. Some areas in a galaxy rich in gas light up with the birth of many stars. These places are called star-forming regions. Every star in the sky, from the smallest and coolest to the biggest and hottest, is part of a galaxy held together by gravity and shaped by dark matter. In the space between galaxies, there is not complete emptiness. There are small amounts of gas, and the effects of dark energy can be found even where matter is very rare. Galaxies are often seen in groups, with many close together. Huge clusters can hold thousands of galaxies. All clusters are wrapped and joined by bridges of dark matter. Sometimes galaxies drift near each other and join together. These meetings are slow and may take hundreds of millions of years. When galaxies join, their shapes change. Stars move around to new paths, clouds of gas get pressed together, and many new stars can be born from the gas and dust. The joining of galaxies is one way they grow larger, and these events leave behind twisting shapes and waves of new, bright stars. Everywhere scientists look, the clues from dark matter are present. The way stars spin, the motion of galaxies, and the paths of light all show that something invisible and powerful is at work. Without dark matter, galaxies would not keep their shapes, and galaxy clusters would fall apart. The universe would look very different. Dark energy works in the other direction, pushing space to grow. Its effects are seen across the universe. By watching very bright objects in faraway galaxies called supernovae, astronomers learned that space is not only growing, it is growing faster as time goes on. The more space expands, the more dark energy there is, and the stronger its push becomes. The discovery of dark matter and dark energy changed how people understand the world. Science is full of mysteries, but it is through searching for answers that new ideas are born. Dark matter and dark energy are two of the deepest puzzles. Every new experiment, every telescope, each computer model adds more data and helps people learn. In the earliest times, after the first atoms, stars, and galaxies formed, most of the structure was controlled by gravity and dark matter. Clusters of galaxies grew as dark matter pulled them together. Stars formed inside gas clouds held by gravity, and galaxies joined into larger groups. Galaxies do not stay still. They travel through space, moving slowly over many billions of years. Gravity, dark matter, and dark energy all play a part in the paths galaxies and clusters take. The shape of the whole universe, its size and its fate depend on these forces and on the hidden forms of matter and energy. Inside galaxies, stars keep being born, shining, growing old, and dying. Exploding stars send new elements into space. Clouds of dust and gas make more stars, and sometimes planets can form around these stars. All the elements needed for life are made inside stars, spread by supernovae, and gathered in the next stars and planets. Even in our own galaxy, the Milky Way, which holds hundreds of billions of stars, dark matter is present. The galaxy spins faster than expected. The stars move in paths that cannot be explained using only the matter we can see. A huge halo of dark matter surrounds the Milky Way and keeps it together. When the Milky Way meets other galaxies, like in the far future with Andromeda, dark matter will play a part in how they combine. Understanding dark matter and dark energy is a challenge. Scientists build new telescopes on the ground and in space to see more galaxies and measure their motions. They build detectors underground, hoping to catch a single particle of dark matter. Each search is part of a bigger effort to understand the universe. The universe itself is shaped over billions of years by the balance of dark matter, dark energy, and gravity. These things decide how galaxies gather, how fast space grows, and what the universe will look like in the far future. Scientists use computers to make models of the universe. They input what is known about dark matter, dark energy, visible matter, and the laws of physics. They run these models forward or backward through billions of years. The results closely match the universe we observe, the patterns of galaxies, the large empty places, and even the way galaxies join into clusters. Most of all, matter in the universe cannot be seen. About 85% of all matter is dark matter. Even more, about 70% of the total energy in the universe is dark energy. Only about 5% is the visible matter that makes up stars, planets, and people. This means most of the universe is hidden. Even so, the small part of matter we know best, the part that makes the things around us, comes from the same process. It was formed in stars, spread out by explosions, gathered together by gravity, and shaped by dark matter into stars, planets, and galaxies. Scientists also consider that there might be more than we yet understand. Some think there could be new forms of matter, or that the rules of gravity might change in different places. For now, all the signs point to a universe where most of what exists is invisible. Stars, galaxies, and planets would not have come together without the hidden support of dark matter. The universe would have grown faster and faster without dark energy, spreading everything too thin for more stars and galaxies to form. The balance of these two hidden things made the world we know possible. As time passes, the universe keeps changing. More stars are born, more galaxies move and combine, and the space between galaxies grows. The push of dark energy grows even stronger, spreading galaxies farther and farther apart. Eventually, the space between most galaxies will get so large that their light will never reach each other again. Still, all life and every planet are built from matter shaped by galaxies, stars, and the invisible hands of dark matter and dark energy. The sky, the earth, every part of every living thing carries this history. The story continues in the way dust collects into planets, and planets circle stars in new and different systems, each one made possible by the forces and materials set in motion at the very start of the universe. Every living thing and every planet in space carries the story of the universe within it. Stars, galaxies, and the hidden parts of the universe shape everything that exists. As stars continued to be born and live out their lives, important changes took place inside them. The story of how the elements were made and how everything in the world was built started with the birth and death of stars. When a star finishes using the hydrogen in its center, it starts to change. Small stars, like some of those you see in the night sky, use their hydrogen slowly. These stars can shine for tens of billions of years. Bigger stars use up their hydrogen much faster and shine many times brighter, but they only live for a few million years. No matter the size, all stars go through changes as they get older. As a star grows older, it can run out of hydrogen in its center. At this stage, the part inside the star gets smaller, while the outside grows bigger and cooler. This change makes the star puff up and shine more softly. If the star is big enough, the center gets hot enough to turn helium into heavier elements like carbon and oxygen by joining atoms together in a process called nuclear fusion. Nuclear fusion is when two light elements join to make a new, heavier element. Each time fusion happens, energy is released. This energy makes the star shine. In the biggest stars, the center becomes hot enough to make even heavier elements. These stars build up layers of elements like onion skins, one inside another. The fusion in these stars creates elements such as neon, magnesium, silicon, sulfur, and finally iron. Iron is special because once it forms, the energy made from fusing more atoms is not enough to stop the center from collapsing. When a lot of iron builds up in the core, the star cannot hold itself together any longer. At that point, the star's life is close to its end. The whole center of the star collapses in just seconds. The outside of the star then blasts away in a supernova explosion. A supernova is one of the brightest events in all the universe. For a short time, one star exploding can shine brighter than an entire galaxy. All the elements built during the star's life and many new ones created in the heat of the explosion are thrown out into space. Supernovae are very important for the universe. They spread heavy elements everywhere. Before stars and supernovae, there was almost only hydrogen and helium in the world. But supernovae fill space with carbon, oxygen, iron, and more. These same elements later join together in clouds that will make new stars, planets, and even the basic materials for life. The atoms in your body, like the calcium in your bones and the iron in your blood, were made long ago inside stars. Not all stars end their lives in a supernova. Some, which are smaller, gently lose their outer layers and leave behind a small, hot core called a white dwarf. A white dwarf is one of the last stages for these stars. It does not shine as brightly as the original star, but glows softly for billions of years, slowly cooling down. In both cases, the material the star gives to space mixes with gas and dust that is already there. Even stranger objects are made from the death of big stars. When a star is truly massive, it can leave behind a neutron star or a black hole. A neutron star is a tiny, very heavy object made almost only of particles called neutrons, with gravity so strong that it squeezes matter very tightly. A black hole is even more extreme. In a black hole, gravity is so intense that nothing, not even light, can escape from it. Black holes and neutron stars can stay in the universe for a very long time, sometimes joining with other objects and changing the environment around them. Every time a star dies, by blowing up in a supernova, by throwing off its outside layers, or by shrinking to a white dwarf, matter is sent back into the galaxy. This material joins with clouds of gas and dust floating in space. Over many millions of years, gravity can pull these clouds together. New stars can be born from the mix of old and new material. In the same regions, heavy elements can slowly build up, making it possible for rocky planets to form. The cycle of stars being born, shining, and dying keeps going again and again in every galaxy. This cycle is how the universe grows richer with the elements needed for planets, air, water, and living things. After many cycles, more and more heavy elements become available. This changes what can be built in the universe. In galaxies everywhere, stars at every stage of life can be found. Young stars shine blue or white, showing they are hot and burning hydrogen fast. Older stars might look yellow, orange, or red as they expand and cool near the ends of their lives. Clouds of gas glow with the light of new stars being born inside them. Other clouds may be darker, hiding new stars that cannot be seen yet. Supernova explosions and the strong winds from big stars blow bubbles in the gas of galaxies. They help mix all the elements. The shock of these explosions can even start other gas clouds to collapse, leading to the birth of new groups of stars. In this way, stars help shape everything else inside the galaxy. Stars are not alone in their work. Gas and dust are always being recycled inside the galaxy, moving between stars and clouds. Sometimes galaxies come close and even mix together. When this happens, clouds of gas and dust are shaken up. Big bursts of new stars can be born as material crashes together. These bursts make some of the brightest spots seen in distant galaxies. As time passes, more and more new stars are made from material that already contains heavy elements. When a new star forms, there might be enough elements like carbon, oxygen, and iron around it for rocky planets to form. In clouds where there is a lot of heavy material, planets can grow bigger and have more complex parts, like mountains, oceans, and even the building blocks for life. Planets themselves are made from the leftovers of stars. In a disk of gas and dust circling a new star, small grains of rock and ice stick together bit by bit. As they grow, gravity pulls them into larger objects. Some planets form from rocks, metals, and ices and stay small and solid like Earth. Others gather thick layers of gas and become much bigger, like Jupiter or Saturn in our own solar system. Moons, asteroids, and comets also come from the material left over after stars are born. Moons form around planets, asteroids from leftover rock, and comets from ice mixed with dust. These small pieces move around stars across billions of years, sometimes bumping into each other, sometimes joining with planets or traveling through space. The energy from stars, along with the mixture of elements made inside them, creates all the parts needed for many kinds of worlds. On Earth, for example, the water, air, soil, rocks, and all life are possible only because stars made elements and sent them into space by exploding and dying. Each generation of stars makes it more likely that new planets will be filled with all kinds of materials. Planets born earlier from simple gas might not have rocks or water, but newer planets, born after many generations of stars, can have all the heavy and complex elements. This makes new types of worlds and even life more possible each time the cycle of stars repeats. Another important part of star life is that the explosion of stars can affect things far away. A nearby supernova can send shockwaves across space, shaking clouds and starting the process of starbirth in new places. In this way, one star dying can help new stars to be born in clouds of gas nearby. The light from supernovae can travel for billions of years. When scientists look far into space, they sometimes see the light from supernovae that exploded long before our solar system even existed. By studying this light, they learn how stars change, how the universe grows, and how the elements were made. In the Milky Way galaxy and other galaxies, scientists are always watching the sky, counting stars and measuring the light and the different elements. They use special instruments to break light into colors and see what kinds of atoms are in stars, gas, and dust. This is how we know that air on Earth has oxygen, or that the iron inside our planet started as part of an exploding star. With modern telescopes, people can see the cycle of star birth and death happening everywhere in the universe. New stars glowing in bright clouds, old stars fading, and the remains of supernovae spreading out across the sky. All these events can be seen by looking at different kinds of light: visible, infrared, ultraviolet, and more. The story of elements continues every day. The Sun, our own star, is now burning hydrogen in its center and making helium. One day the Sun will expand into a red giant, then shed its outside layers and become a white dwarf. The materials from the Sun will mix into the galaxy, just as the material from other stars before it. Everything in our solar system, planets, moons, air, and even each person, will carry the signs of these changes. The building of elements in stars is the reason the universe could change from being almost only hydrogen and helium to a place with water, rocks, mountains, plants, and animals. Every breath, every bite of food, every part of the world around you started as atoms born in stars. Over time, this never-ending story lets new worlds appear, with new possibilities for life. The universe keeps changing, with every star and every planet adding a new chapter. As more elements are made and spread out, the galaxies fill with stars of every age, worlds of every shape, and perhaps life in places far from Earth. Scientists continue to explore the stars and their secrets. Powerful telescopes on Earth and in space let people look back across billions of years to see how stars first began to make the elements. Every bit of knowledge helps us see ourselves as part of the universe's long story, a story written in starlight, in dust, and in every stone, drop of water and living thing. Inside you, there are atoms that were once in the heart of a giant star. The world you know is possible because of changes deep inside stars and the explosions that sent elements everywhere. Everything, air, water, earth, and life, is tied to the life and death of stars. The story of how the elements are made is the story of how the universe becomes richer, more interesting, and more full of new things with every passing year. The atoms from ancient stars drifted through galaxies, joining with gas and dust that filled the empty spaces. Everywhere in the universe, the cycle of star birth and death continued, mixing new elements with the simplest ones made soon after the Big Bang. This constant movement and mixing made the universe a place where new things could be built. The next important step was the birth of planets and systems of planets going around stars. Over long periods of time, clouds of gas and dust slowly came together through the action of gravity. As more material gathered, the center of each cloud became very warm and dense. Eventually, a new star would form at the heart of the spinning disk of gas and dust, shining steadily as it began its life. Around this newborn star, leftover dust and gas did not disappear. Instead, these pieces began to stick together little by little. At first, the bits of dust were tiny, sometimes even too small to see with an eye. These tiny grains gently touched each other and stuck. As time passed, these clumps grew bigger and heavier, turning into small rocks. The rocks kept bumping into each other, making even larger chunks called planetesimals. These could be a few kilometers across or even much larger. Every time two planetesimals bumped into each other and joined, more mass was added to the growing body. Gravity started to play a bigger part as these bodies grew. Larger planetesimals pulled in smaller ones, making bigger and bigger objects. After many millions of years, some planetesimals became large enough to be called protoplanets. These early planets moved in wide orbits around their star. Some protoplanets kept getting bigger. If a protoplanet grew big enough, its gravity could gather a thick layer of gas from the disk around it. If there was a lot of gas, especially in the farther parts of the disk, these protoplanets became giant planets, with thick atmospheres made mostly of hydrogen and helium. If there was less gas and more dust, the protoplanets stayed smaller and rocky, without thick atmospheres. In this way, different kinds of planets were born in every system. Some were large balls of gas, like Jupiter and Saturn in our own solar system. Others were smaller and made of rock and metal, like Earth, Mars, Venus, and Mercury. The process of planet building is not fast. In most cases, it takes tens of millions of years or more. Around new stars, there were many objects that did not turn into full planets. Some of these became moons, circling larger bodies. Others became asteroids, chunks of rock and metal left over from the planet-making process. Some pieces, filled with ice and dust, became comets, moving in wide orbits far from their stars, and sometimes coming close, leaving trails of gas and dust behind. In the early days of a planetary system, things were very busy and sometimes violent. Many rocks, planetesimals, and protoplanets crashed into each other, breaking apart or joining together. Large impacts could shape the course of a planet's history. For instance, a huge impact is believed to have helped form Earth's moon, with a smaller planet hitting Earth long ago and throwing out material that later came together to orbit the Earth. As the system calmed down and fewer large collisions happened, the planets began to follow more stable paths around their stars. Each planet, large or small, found its place in the system. Some had many moons, some had rings made of dust and ice, and some were alone. Earth is just one planet among many in the solar system. The story of how Earth formed helps explain how other planets may have formed too. About 4,600,000,000 years ago, the cloud of dust and gas that would become our solar system began to flatten into a spinning disk. Most of the matter moved toward the center, forming the sun, while the rest gathered in different places, becoming planets, moons, asteroids, and comets. Earth started as a collection of dust and rock, slowly joining with other pieces with every collision. While it grew, it became hot inside. This heat, from impacts and from radioactive elements, melted much of the inside of early Earth. Heavy materials like iron and nickel sank to the center to form the core. Lighter rocks floated to the outside, making the crust and the early continents. As Earth cooled, water began to collect on the surface. Some water may have come from steam cooling down, and some may have come from icy comets and asteroids that hit the planet. In time, oceans, rivers, and lakes appeared. The early atmosphere was very different from the one we have today, but it held the gases released from volcanoes and from other early changes on Earth. For millions of years after Earth was formed, it was not ready for life. The world was very hot, with volcanoes and impacts shaping the land. Slowly, as the planet cooled and more water formed, things began to settle. The sun shone in the sky, and the moon, Earth's early companion, moved in orbit nearby, affecting the tides and the speed of Earth's spin. Other planets in the solar system formed in similar ways, though each followed a different path. Mars, farther from the sun, ended up smaller and colder than Earth, with a thin atmosphere and signs that water once flowed on its surface. Venus, closer to the sun than Earth, became very hot, with thick clouds of acid and a surface too warm for water to last. Mercury, closest to the sun, lost most of its early gases and became a small, rocky world covered in craters. Beyond the inner rocky planets, the gas and ice giants grew much larger. Jupiter and Saturn gained thick layers of hydrogen and helium, growing large enough to have many moons and even faint rings. Farther out, Uranus and Neptune became icy giants, with water, ammonia, and methane deep inside. Every planet, moon, and asteroid holds clues about how the early solar system changed and grew. Scientists study the rocks on the moon, the ice on comets, and the surface of Mars to learn about the birth of our system. These studies show that even after the planets formed, the solar system continued to change, with impacts and moving objects shaping everything for billions of years. While the planets and smaller bodies were taking shape, the sun went through its own changes. Like all stars, the sun was born from a cloud of gas and dust. Once enough material gathered, nuclear fusion started at its center, and the sun began to shine. The energy and light from the sun gave warmth to the planets and pushed away some of the gas and dust left over from planet formation. Over time, the leftover objects like asteroids and comets stayed in certain areas of the solar system. The asteroid belt between Mars and Jupiter is a wide ring of rocks and small bodies. The Kuiper Belt, beyond Neptune, and the Oort cloud, far past Pluto, hold many icy bodies that move slowly around the Sun. The story of planet formation is not only about our own solar system. Everywhere in the universe, around billions of stars, clouds of gas and dust gather to make new systems. With powerful telescopes, scientists have found thousands of planets orbiting other stars. These are called exoplanets. Some are large gas giants, others are rocky worlds like Earth or Mars, and some are even bigger or smaller than any planet in our solar system. Some exoplanets orbit very close to their stars, completing a full circle in only a few days. Others orbit far away, taking hundreds or thousands of years to travel once around their sun. A few of these planets may have the right conditions for water. Liquid water is very important because it makes life possible on Earth. Around young stars, astronomers have seen disks of dust and gas, bright rings and shadows that show where planets are being born now. These places are sometimes called planet nurseries. By watching these disks with special telescopes, scientists can see how planets collect matter, carve paths through the gas, and join dust together to grow. The formation of a planet is just the first step. The surface and air of a planet keep changing for billions of years. On Earth, volcanoes, rain, wind, and the slow movement of the continents help shape the land. Water moves rocks and soil, making rivers and lakes. Air and sunlight give energy to all living things. Many factors help decide what a planet becomes. Size, distance from its star, the mix of elements, and what happens in the early years all make a difference. On Earth, all these things came together to create a world with oceans and an atmosphere where life could begin and grow. Life on Earth started very simply, probably in the oceans more than 3 billion years ago. Tiny living things grew, changed, and spread. Over many millions of years, new forms of life grew more complex, leading to plants, animals, and, much later, people. As Earth changed, so did the other planets. Some, like Mars, lost their thick atmospheres and water as the sun's energy blew gases away. Venus became trapped in a thick, hot cloud layer. Others, like Jupiter and Saturn, kept their gas and grew very large. Every piece of dust, every rock, every drop of water on Earth, and every breath of air comes from the same atoms made in ancient stars. Each one passed through cloud after cloud, star after star, sometimes being part of other planets, moons, or even living things, before ending up in your body or in the ground beneath your feet. Scientists still study how planets form, why some get large and others stay small, and what makes some able to support life. Missions send robots to Mars, to asteroids, and to comets to collect clues from the past and piece together the early days of the solar system. Each mission brings new information, showing that planet building is complicated with many surprises. Planet formation is a process that keeps happening in the universe. Around distant stars, disks of gas and dust can be seen where new planets may grow. Some of these systems are young, others are already billions of years old. The same laws of nature guide every star, every planet, everywhere, always joining dust and gas by gravity and shaping new worlds. The Earth and everything on it, that is, the rocks, the oceans, the air, the living things, are made of atoms that have gone through stars, explosions, gas clouds, and more. The journey of the atoms is long, filled with change and mixing, always moving from one form to another. Each new world, no matter where in space, is part of a very old and beautiful story. From the beginning, the birth of the solar system and the planets that circle the sun were possible because of changes that happened over billions of years. The story will always continue. Even now, new stars and planets are born in distant clouds, ready to become new worlds with their own stories. All the while, the universe carries the memory of every atom and every world that has ever existed, holding the past, the present, and the future together in the endless journey of creation. New stars and planets continue to be born in distant places of the universe, each beginning a new story. The world we live in today, with all its life and beauty, is the result of billions of years of change. Yet even as we learn how everything formed, new questions appear. The universe is full of surprises. Scientists keep searching for answers and wonder about everything that is not yet understood. No matter how much has been discovered, some mysteries remain. One of the greatest questions is about the very beginning of the universe. People have tried to know what happened at the first moment when time, space, matter, and energy all appeared. The idea of the Big Bang is the closest answer science has found, but what was before that moment is still unknown. Some scientists think the question itself is not simple, because if time started at the Big Bang, then there was no before in the way we understand. Trying to think about nothing and how something can come from it is very hard. Other ideas have been suggested. Some scientists think there may be different universes, not just ours. The idea is that maybe, like bubbles in a bath, there could be other bubbles that are other universes, each with their own space and time, each with their own beginnings and endings. No one has seen proof of other universes, but the idea is studied and explored. Scientists try to make new theories and test them, always asking if the universe we know is the only one possible. Time itself is a part of the mystery. If time began with the Big Bang, can we even ask what happened before? Was there a cause, or did time and space simply begin together? The laws of science make it difficult to know. Even today's biggest machines and sharpest minds cannot see past that wall. Each new attempt to look further back adds more questions and sometimes more puzzles. Another question is why the laws of the universe are the way they are. If the force of gravity were just a little stronger or weaker, or if the particle masses and forces were changed just a tiny bit, stars might never form. Planets might never exist, and there could be no life. The numbers and rules of the universe seem finely balanced for the world we see. People wonder why this is so. Is there a special reason, or is it just one of many ways things could be? Scientists test these questions using experiments, math, and by looking at the stars and galaxies. They use telescopes in space and on the ground, watching for tiny differences in the light from far away. They build computers that run models of the universe, changing the rules and seeing what kind of worlds would appear. Every discovery helps, but the puzzle is still large. The search for knowledge brings people together. Every country, culture, and person shares one world. Everyone looks up at the sky and can wonder about the same stars. Science is not only about answers, but about the questions too. Each person is part of the story of the universe, and each person adds new ideas. There are other mysteries as well. Scientists have found out that most of the universe is made of things we cannot see or touch. This includes dark matter and dark energy. Dark matter holds galaxies together, but it cannot be seen. Dark energy pushes the universe to expand faster and faster. They make up almost all the stuff in the universe, yet almost nothing is known about what they are. Machines and telescopes keep improving, and scientists try to catch a sign of dark matter or find a deeper explanation of dark energy. Sometimes an idea is found to be wrong, so researchers must try something new. Other times, a small clue leads to a big breakthrough. Science takes patience and an open mind. Every little bit helps build the picture of what everything is made of and where it comes from. The way the universe began, the way stars were made, and how planets and life appeared are all linked together. The atoms in your body were once in ancient stars. The air you breathe, the water you drink, and the ground you walk on all come from the changes that happened over billions of years. This connection is real, and it is what makes each person part of the universe's story. Some people wonder about the future. The universe is still changing. Stars are being born, and others are dying. Galaxies move farther apart as space grows. One day, very far from now, the last stars will shine and use up their fuel. After many billions of years, there may be only darkness, with no new stars born. Or perhaps new events will change the world again in a way nobody expects. The universe is a place of both endings and beginnings. Life on Earth is just one small part of everything. Over time, life has filled oceans, land, and air. New kinds of plants and animals have appeared and disappeared. Even people are very new compared to the age of stars and galaxies. The search for life in other places is another mystery. Scientists look for planets around other stars and search for signs that water or even simple life might exist somewhere else. The universe is huge, with billions of galaxies, each full of stars and planets. With so many places, it is possible that life could appear elsewhere. Telescopes and satellites search for tiny changes in starlight to find planets with the right conditions. The work is slow and the clues are small, but the hope remains that someday people will find proof that life is not alone. Learning how the universe began also helps to understand how people fit into it. The same rules that shape stars and galaxies also shape life and the world. Every question opens more questions. Why do people exist? Why is there something instead of nothing? Why do the laws of nature allow life to appear? Science does not have all the answers, but it helps people to wonder, explore, and learn. Many discoveries come from people looking at the sky and asking questions. Over thousands of years, different cultures invented ways to study the stars, watch the seasons, and make sense of the sky. The urge to learn is part of being human. When questions are asked, new tools and methods are made to answer them. Every new answer leads to more questions. The first telescopes showed that planets orbit the sun. Better telescopes found that stars are faraway suns. Then scientists found that the Milky Way is just one galaxy among billions. Now we know the universe is even bigger than anyone first believed. The more that is learned, the more there is to understand. Today, science moves forward by joining together ideas from many fields. Physicists, astronomers, chemists, biologists, and others work together. They study the tiniest particles, the largest galaxies, and everything in between. Learning about the universe's beginning takes all types of science, from the study of light to the oldest rocks on Earth. Technology is always advancing. Telescopes in space can see the oldest light from soon after the Big Bang. Spacecraft visit planets, moons, and asteroids to bring back clues about the history of our solar system. Computers run huge models, watching whole galaxies form in simulated worlds. Each new tool brings another piece to the picture. The search to understand the universe will never really end. The more science discovers, the bigger the universe seems. Every new observation shows new details. Each puzzle solved uncovers something new to explore. People today are part of the same journey as those who first looked at the stars thousands of years ago. Sometimes, discoveries lead to big changes in how people see the world. When it was found that Earth goes around the sun, not the other way, it changed the way people thought about their place in the universe. Knowing there are billions of other galaxies changed things again. Every time ideas grow, the sense of wonder grows too. Questions about the universe are not only for scientists. Each person can ask questions, look up and think about the world. Wondering about where everything comes from or what will happen in the future is a part of being human. In schools, in books, and in conversation, the story of the universe is shared. As people keep asking and exploring, small answers collect into a larger understanding. The curiosity of a young child, the careful work of scientists, and the long history of observing the sky all join together. Step by step, more is learned, changing how people see themselves and their place in the world. There is much that can never be known for sure. The very edge of the universe, what happened before time began, and why there is something instead of nothing, may remain mysteries. Yet the search is as important as the answers. Each discovery brings new technology, new ideas, and sometimes even new questions that nobody had thought to ask before. The story of the universe is one that connects all people, all living things, and all things that exist. To learn about the universe is also to learn about yourself. The same atoms that once were in distant stars now make up your body. Each breath and each step is part of that history. By learning, by asking, and by searching, people are linked to a story billions of years old. This story is always growing, always changing, and always inviting new questions. As new stars are born, as planets form, as life changes and grows, the universe's story continues. All knowledge and discovery are steps along a never-ending path. The universe is not only something that is studied, it is a place everyone belongs to. Each question and each moment of wonder brings everyone closer to understanding where everything came from, what it is made of, and what might come next. The future is unknown, but human curiosity, hope, and the search for knowledge remain. The universe waits to be explored with every person taking part in the story. The journey from the first moment to today and beyond will always continue, as long as there is someone looking up and asking, how did everything begin, and what will become of it all?